All right, here's a video to help you with homework 8. So the first problem is a pedostatic probe, and it's hooked to a manometer. And you're using the pedostatic equation for velocity. So just remember that V equals the square root of 2 delta P over rho. Okay. Now, you're looking at air, so this density is of air. Okay. Now, delta P, you can use Bernoulli's pretty much on these 2 points. It's static, and it's just rho GH. Okay. Or technically, it'd be delta P rho G delta H. Okay. But this density here is of water. Problem 2. You have this tank. It's pressurized with 3 atmospheres inside. You want to figure out how high it is. And then I want you to make a plot of H, which is on the y-axis, as a function of different water level in the tank. Okay, so this value. So you're going to have H versus, let's put HT. Okay. We can do HT of the tank. Okay. So what I would do is just do Bernoulli's. Bernoulli's is from here to the exit, and then do Bernoulli's from there to here, because energy is conserved from state to state. Okay. And then what I would do is make an equation for H based on all of these. Don't plug numbers in till the very end, and you'll end up seeing how you can relate. I would call this HT, and you can then figure out how to make the plot. Okay. What I would do is maybe go by 1. So maybe your HT starts from 1, 2, 3 to 15. Okay. All right, again, Bernoulli's from 1 to 2, and then 2 to 3. Don't plug numbers until the very end, because you can see that maybe you can find an equation for H. All right, last question is basically you have this siphon. You want to calculate the flow rate through the nozzle and the pressures at A and B. Okay, we give you the dimensions for X and Y in the problem. So really what you're going to do is, this is open. I would always call this state 1. And then maybe the exit here, state 2. State 1's open to the atmosphere. And so you're going to do Bernoulli's from 1 to 2, from 1 to A, and 1 to B. Or you could do A to B. It doesn't matter. Okay. Or you could do B to 2. Okay. But it has to be the direction that the water's flowing, right? Okay. I would possibly do this one first. That might help you find the velocity, and the velocity is the same at A and B and 2. Okay. So you're going to do Bernoulli's 3 times. You got to have 3 equations for Bernoulli's for different points. Highly recommend doing 1 to 2 first to find velocity. And I believe it gives you the area. Yep. 25. It gives you the diameter of 25 millimeters. So you can figure out, that's the exit here, and they give you the OD of that. Okay. So try it out. Let me know if you have questions, but this should help you with this homework.